Thank you so much, Niknaz, and well, welcome everybody to the session, and also hello to all my co-speakers, Jack, Cesar, and Nathan. It's great to be with you guys. So I'm gonna share my screen very quickly, and Niknaz, if you could let me know
Sure.
everything looks in order.
Yeah. Right.
Yeah. Okay. Perfect. Um, and so we are One Click LCA. So we are a sustainability platform for projects and products. So we are one of the oldest life cycle assessment tools available in the market. We've been around for nearly 25 years now, um, headquartered in Helsinki, Finland, but we have a global presence and we have regional tools all over the world. And I'm like Niknaz mentioned, part of the North America team where we have North America specific AEC and manufacturing sustainability tools. A quick note on why we're doing what we're doing. You know, as construction and manufacturing professionals, and I hope a lot of the viewers today are that. Um, we cause nearly half of the environmental damage when compared to all the other industries present in the world. And if we look at the numbers, and I won't go deep into each of them, but almost around 50% of many different environmental lenses that you can put on, you can relate them back to the AEC industry, whether it's damage caused by creation of new products and materials and manufactured products, or whether it's whole buildings and the way they function and the amount of energy buildings use in their lifetime, etc. And having said that, on the right, you can see that we're not stopping building. We are in fact going to keep building a lot in the next decades to come. So, which is why it's super critical that as an industry we look at things like life cycle assessments and sustainability evaluations, using all the tools that we have on the webinar today. Um, a quick look at some of our clients. Like I mentioned, we work across both the architecture engineering side as well as on the manufacturing side of things. And you can see there's some typical names from these various industries that use One Click LCA in their um, everyday workflows in order to sort of figure out what the environmental and carbon impacts of their products are. And then figuring out ways to sort of reduce those impacts using the software. Um, it, to say anything about One Click LCA without this image would not be possible. So this is what a life cycle assessment is. So I won't again go deep into a big lecture on LCAs or anything like that, but it's always good to remember that what we're trying to do here is analyze projects from their very conception, which is what are the products and materials that are going into each project, and where do these materials come from, where are they manufactured, how much energy or carbon or other environmental impacts does it take to bring them and to make those materials in the first place, and then all the way to end of life, going through the use stage of a building, constructing the project in the first place, and then the use stage, and then finally the end of life, what happens to buildings and materials at the end of their life cycle. So this is at the very base of it, what you're trying to do on the software when you are analyzing different kinds of projects on it. And at the same time, building material manufacturers can go on the software and do this very exercise, but for their product. So you can figure out, okay, for this kind of concrete or this kind of steel or this kind of wood, what is the life cycle impact? And those numbers then can be used to sort of figure out project level life cycle assessments. So this is what ultimately the software is intended to do. Um, and 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 you guys will see that this is like a general theme across today's talks, that a lot of these evaluations can be done across various different stages of a design process of a project, whether it's early phase design, project stage, and then all the way to specification and documentation. You can do LCAs at various points. But the big question is, at which point do you have the power to influence design and specification choices using environmental data? That's where the graph becomes a little distorted. So you can see that the potential to reduce CO2 emissions at an early phase of a design are much higher during the site selection and the conceptual design phase, as opposed to when you're at the construction stage, where it's not really possible for you to take decisions around, okay, can we change certain materials that we're using? Can we change certain processes that we're using on the project? And the cost of making these changes, let's say to change materials or to change design, generally speaking, in terms of the time spent and the effort required to come up with these designs in the first place, exponentially increases. So not only is it going to have lower potential to reduce CO2 at a later stage of a project, the cost of making that change is going to be um, very high. So the highest potential always lies at an early stage of the design process, and that's very much what the intention of the tool is, that you are able to conduct these LCA evaluations at any stage of the of your given project, and then take them all the way to documentation and submission of um, to necessary certifications and things like that. Um, this is more of a pictorial representation of what those various stages and those software tools on One Click LCA look like. So at a pre-project stage, you can do target setting. You can, we have something called Carbon Designer 3D, which is at very early stage. You can figure out that for the kind of project that we are envisioning, which could be, let's say, an office building of a certain size in a certain location using a certain frame typology and certain materials, on average, what do we expect the carbon emissions of that project to be? um, as a side note, we talk to so many people in the industry. Sometimes it's hard for people to make sense of carbon numbers. You tell them, this building will have X amounts of carbon per square feet, and they say, okay, but what does that mean? Is it high? Is it low? um, and those are the kind of questions you can answer at this early stage, where you can see, okay, looks like, conceptually speaking, on average, this building should have this much carbon per unit area, and as compared to the industry, it's probably lower or more or less. So you could find things like that, and probably at an early stage you're able to find, okay, the amount of carbon looks very high. How do we reduce it? And then as you move forward with your design process, let's say during your design stage, um, One Click integrates with Autodesk Revit, with you can even upload your bill of materials and many other sort of design tools. I know IES and then several other sort of early stage design modeling tools as well. You can have One Click LCA plugins, get all that design data into the tool, and you are able to conduct the lifecycle assessments. And towards the later stages of the uh, of the design process, you are able to sort of analyze and create final reports and use those for your submittals. Similar to the construction, we like I said, we also work with manufacturers of building materials, and they also can, they also have sort of like a few stages that they go through in order to create EPDs, or environmental product declarations, for their products. So as a tool, we understand that being able to do environmental evaluations, being able to do LCAs and EPDs has a few barriers to adoption. Typically, you could categorize those barriers to adoption under 4 categories. Firstly, just the amount of LCA data that's out there in the world, and being able to really find, okay, what is the right data point to use for my project's materials and the various processes that you're using, can get terribly complex, which is the second point, which is about complexity, finding the right data, finding the right calculations methodology, and things like that, to have a comprehensive analysis. And then the workload, the sheer amount of effort that it might end up taking someone to do all this, let's say, manually, and to go one by one on each data point, can be quite laborious, and it's almost like a research project in itself. Um, and then lastly, the various standards that exist in the market. The LCAs have to be ISO compliant, and certain certain things that need to be made sure that are okay with an LCA for it to be a completely verified LCA. So these are the 4 big challenges that we see in the market, and as a tool, our aim is to have all these challenges solved on the platform. So once you start using, say, One Click LCA, you know that for sure it's compliant with specific standards. You get all possible LCA databases on the tool that you can then potentially um, use for your projects. And it reduces workloads because of all the various automations and capabilities within the tool to automatically take your designs and be able to conduct these evaluations on the back end. I know, Nick Naz, you mentioned that today's session also focuses a bit on AI. So I wanted to also touch upon a few things that we are trying to incorporate in terms of AI. AI is the big buzzword now, and everybody's talking about it. But I guess the question that's better asked is, what problems are you trying to solve using something like AI, as opposed to just using it generally? So there are a few things that we see can be solved, using AI on the software. For example, quality data and being able to find it fast enough, cost of creating manufacturer EPDs in general. For example, when material manufacturers make all their environmental data points, it can be a laborious process. It can take time, effort, and hence sometimes thousands of dollars in cost. So how do we automate that, and bringing some AI technology there to be able to sort of take some of the details of the product manufacturing process, and being able to automatically match those with existing environmental data points. Um, and then integrations with BIM tools and with bill of materials itself, those integrations can become a lot faster, much more efficient, and much more accurate using AI, and the behavior of other designers who worked on such tools before. Um, Hence reducing the manual and labor intensive processes, you can say, of doing these things in the first place. And then finally, AI also helps with early stage design optioneering, where you're in an early stage of the design. You're asking yourself, okay, which direction should we go if we want to reduce carbon emissions of this project? That's where AI can fit in as well. How am I doing on time, Nicknaz? Do I have another minute?
Maybe a minute. Yeah, one more minute. If you can
Okay,
wrap up, would be great. Yeah.
perfect. Yeah, so I'll go through these quickly. These are just screenshots of the things that I've been talking about. And of course, if someone's interested, feel free to reach out to me separately, and we can go over in much more detail with the demo. But this is a screenshot from early stage, AI generated optionalities that you can generate on the software. Then at a later stage, when you're doing data imports, identifying, classifying, and mapping materials has become a lot faster and is becoming constantly improved on the software, which is to say every possible material data point on your project can be matched with the right LCA data point. Um, and these are all screenshots basically aiming to show that. And then even searching for materials, like, for example, this is very naive, but it in a way saying, find me a low carbon concrete in California. Now it's possible to have much more accurate results for something like that, which are based on your location, your specification, and the type of material you're looking for, rather than just a general result of a bunch of materials in your area. Lastly, I'll leave everyone with this. There's many case studies that you can find on the One Click LCA website, but a couple that I have screenshots of here. There's Half Design, based in Canada, did a project in Toronto, and they were able to lower embodied carbon by a significant amount. And there were a few strategies, and you can find this on our website as well, on what kind of interventions they did for this specific project to be able to reduce embodied carbon. There's lower concrete carbon typologies that they use. There's hempcrete blocks that they use instead of CMU, etc. So I won't go through all of them, but an excellent case study of how people use tools like us to be able to achieve these outcomes. And similarly, Arcadis infrastructure project also achieved a 30% carbon reduction, and there were some specific strategies that they followed for doing that. And lastly, this is me, and that's the QR code that goes to me in my calendar. And if anyone's interested, feel free to reach out. Happy to have a conversation, a demo, and discuss more. And thank you. This is all for me.
Wonderful. Thanks so much, Amar, for the insightful presentation and all the great